In this part of the course, we're going to talk about application hacking. Now, we've already considered system hacking, where we go after the operating system, and we've looked at network hacking, where you go actually after the network infrastructure that the host resides on. So now we're going to talk about the applications that actually sit on the box. Now, application hacking basically targets software and programs that reside on a system, and this might mean a server, it might mean a workstation, or basically any other host. In terms of software, you could conceivably say that this means databases, mobile applets, productivity software like Microsoft Word, for example. It also might mean any network-connected programs or applications that rely on network connections that maybe service remote clients. You could also say this applies to utilities and commands and so forth. So it really could be anything that sits on the operating system that's not part of the operating system itself, that was installed later. Now, application hacking basically takes advantage of weaknesses that could be in a program. And this could be unchecked buffers, it could be input validation issues, and so forth. And these issues could lead to things like execution of arbitrary code by the hacker. It could lead to privileged access and then later elevated privileges. It also could lead to unauthorized data access, where a hacker is able to access data they shouldn't and either delete or steal that data. It also, in the end, might lead to a denial of service condition for the host itself. Now, these weaknesses in the software applications, things like I mentioned, include unchecked buffers, lack of input validation, maybe even weak permissions or unsecure network connections. Maybe the application is using something like FTP or Telnet, for example. And weak authentication, weak password authentication possibly might be an issue. So in some cases, it might be weaknesses in the applications themselves, but in other cases, it might be weaknesses in the environment that the application sits on. And maybe the application is not prepared to deal with some of the things that it expects the OS or the network to protect it from. In any case, application hacking takes advantage of these weaknesses that I mentioned that are in the application itself. But typically, they are attacked through the network and the operating system. You don't just attack an application from a remote host. You've got to go through the network to get there, and most of the time you have to go through the operating system security mechanisms, things like the built-in firewall or permission sets and so forth. You have to go through all that to get to the application. However, if the application is weak and you have very insufficient protections on the network or the operating system, then you can get right through to the application itself. So that's an example of defense in depth, where all three of those levels need to be secured. Now, in some cases, exploit code might be needed to take advantage of the different weaknesses that could be built into applications. Things like small buffers or unchecked validation parameters and so forth. Exploit code could be needed to take advantage of those, but it doesn't have to be that way. Sometimes just sending weird traffic or doing something that would cause the application to error out or crash could be taking advantage of a particular weakness in an app. Now, we're going to talk about buffer flows a little bit later, but basically they're one of the primary means to attack software programs, probably one of the more popular ones that hackers use today. And in this case, data is intentionally written to a particular buffer, possibly a memory address that will only hold certain amounts of data. And more data that it can hold is written to it, and it overflows that memory address, for example, spills into other memory addresses, and overwrites or corrupts that data itself. And this could cause an application to crash, or even in some cases spit up a command prompt. Now, mobile applications we'll also discuss, and they're increasingly becoming targets of hackers. And it really doesn't matter what kind of phone you have or tablet. It doesn't matter if it's an Apple device or an Android device or a Windows mobile device. It doesn't matter. All of these different mobile devices are susceptible to attack, to application attacks, as well as others. And we'll talk about those a little bit later. Web applications also suffer from some of these same vulnerabilities that we'll talk about, although in some cases they also suffer from others because of the fact that they inherently face the internet and are unprotected. So over the next few sessions, we're going to discuss a few things about application hacking. We'll give you a couple of demonstrations, and hopefully by the end of this chapter, you'll have a better appreciation of what hackers can do and maybe some of the methods they use to attack applications that reside on hosts. During these next two segments, I want to talk to you about buffer overflows a little bit more in depth. I want to tell you about how they work, and I want to show you an example of a simplistic buffer overflow attack. Now, buffer overflows are basically common attacks that are designed to overwrite a memory buffer and cause damage to an application. These overflows can cause system crashes. It can allow the attacker to execute any arbitrary commands or code that they want, or it can even return a command shell in some cases. Now, this buffer overflow code can be written in a wide variety of languages, so you have to have a little bit of programming skills. Not a lot, but at least enough. Now, C and C++ seem to be very popular languages to write buffer overflows in, and that's what I'm going to show you. Now, let me explain a little bit about how buffer overflows work. Now, this is very generic, and some buffer overflows work a little bit differently. But in general, in a buffer overflow attack, what happens is in the application, a buffer parameter is set. It could be an input parameter, for example, and allow only so many characters to be in the buffer. Now, data is written to this buffer that may exceed that set parameter in size. In other words, if the buffer is for 15 characters and the input is 20 characters from a string, that string is transferred to that buffer and it's too big to fit in there, so it overflows it. The buffer overflows. Data can be written to adjacent memory addresses or adjacent buffers or locations in memory. Any existing data that happens to be in those addresses is overwritten or corrupted. Now, in most cases, the application may not handle the error very well and may not know what to do with this condition. So a wide variety of things could happen. It could freeze up, it could crash, it could execute any commands that are added to the overflow input string. It could also return a command prompt. So it really depends upon what it will do, and hackers will typically write buffer overflows based upon documented exploits and vulnerabilities in an application, so they know exactly what it will do and they know how to write it to get it to do exactly what they want it to do. Now, I'm going to do a demonstration here in a moment of a piece of code, and this is actually the piece of code I'm going to do. And this is a very simple program, buffer_test.c, and this is a screenshot of the code in gedit. And I'll bring this up in the next session and show you how it works. But basically, just to go through it real quick, it sets a buffer length of 15 characters. And this is a very simple program. It doesn't really do much of anything except show some things on the screen. It prints enter the password. And the password is I love VTC. It's embedded in this code here. Now, if the wrong password is entered, then it jumps and says wrong password. If the correct password is entered after it does the string compare to the buffer right there, if the correct password is entered, then it allows you to proceed, and it says, it prints the screen, you now have full root level access. Now, obviously, this is just a dummy program. We're going to be logged in as root on the Linux box anyway, so it really doesn't matter. But this is just to kind of to demonstrate how this buffer overflow concept works. So I'm going to go ahead and run this program in a moment on the CentOS box. And what we'll have to do first is compile it and then run it. So that's what we're going to do in this next session. Let's go ahead and take a look at that. We're in our CentOS VM, and I have this buffer_test.c program open in gedit, and we just went through it in our previous session, so you know basically what it should do. So what I want to do now is go ahead and close this and go to a shell. And the first thing we need to do is compile this. So we're going to use the GCC compiler, and what I'm going to do is say GCC, and we're going to say buffer_test.c, and we're going to use the -o for output. Let's call it buffer1. We'll just call it that as a program. So it's going to compile this and give us this program back. And we did get a little bit of an error, but that's not a big deal. And it does warn us that the getS function is dangerous and should not be used. And there's a reason for that. And that's actually why we use it, is for buffer overflows. So now that we've done that, what we want to do is we're going to change the permissions of this just to make sure it'll run with the right permissions. And it's going to say buffer1. So now I want to execute buffer1, and it's going to prompt us for the password, and I'm going to put I love VTC. And correct password, I now have full root level access. Well, I already do anyway, so that's not a big deal. So let's clear this, so we know that it works. Let's clear it, and let's run it again. So // buffer1. Enter the password. And this time, we know that we have a 15-character buffer, so let's this time enter a bunch of other stuff. So that's more than 15 characters. Let's enter. It told us wrong password, but because we overflowed the buffer, it still gave us root level access. Now we could run another test just to make sure that the wrong password that meets those characters would still give us wrong access. So let's do that. So let's say buffer1, enter the password. I'm just going to put PW for password. So we know that entering the wrong password will give us wrong password, but yet above, when we entered the wrong password, we still got full root level access because we overflowed the buffers. Now, sometimes another thing you can do is get arbitrary commands executed for you. So let's try that. Let's clear this. And we're going to do this again. And let's enter the password 123456789 123456789, and then let's say cat etsy shadow. And then this may or may not work. Wrong password, full root level access, but we got a segmentation fault, the core dumped. So we didn't get our arbitrary command executed, but that does happen with some buffers, some buffer overflow exploits. So that was just a quick demonstration, a very simple one, a very simplistic one, just to show you how a buffer overflow can work. We overflowed the buffer, but we still got the quote-unquote full root level access. So an actual programmer, an actual hacker could probably have done a better job of writing a true exploit, a true buffer overflow exploit, and then executed it on an actual application. But it just kind of gives you the theory behind it. So anyway, that's buffer overflows, how they work, and we saw a really simple one. We mentioned earlier about mobile applications and how susceptible they are to hacking. Mobile devices are ubiquitous in today's society, so obviously hackers are going to go after them because people are increasingly putting their personal information on them. In fact, they're almost using them as computer replacements, and they're connected all over the place, to wireless networks, to the corporate network, to the home, to the PC, everything. So obviously they're a big target. Mobile applications in general are being increasingly targeted by these hackers, and again, it doesn't matter what kind of mobile operating system, whether it's iOS or Android or Windows, it doesn't matter. It also doesn't matter what kind of device, manufacturer, or vendor it is. Now, obviously, there are some devices that may lend themselves a little bit more to hacking attempts in some operating systems as well as some apps, but by and large, it's almost even across the board. Now, attacks include those that could attack mobile apps, the data, and obviously the device itself. When we're talking mobile apps, we're talking applications that come from, say, the App Store or the Apple Store or whatever, Google Play, whatever have you. In some cases, phones can obviously use applications that don't come from a reputable place. In Android, you can get apps from other places. You don't necessarily have to get them from Google Play, for example. Now, obviously, the attack methods can be a little bit different for mobile devices, but frequently you'll find that they're almost the same as you would use for a typical host. Malicious code in some cases, theft or loss of the device, and obviously social engineering. That's a big one because people have mobile devices and not every person is definitely trained on securing a mobile device. So sometimes social engineering attempts can actually be easier over a mobile device. Now, goals obviously are data theft or destruction, stealing someone's personal data, their credit card and banking information, which is increasingly being kept on phones, obviously, stealing their credentials, passwords, and so forth, any kind of personal data, and in some cases, privacy invasion, maybe through geolocation or whatever. And obviously, everybody's connected to social media through these mobile devices, so that provides an avenue for them to get into the social media and get information that they may not otherwise be able to get. In some cases, mobile devices are also connected, say, to the enterprise network. And a lot of these enterprise networks aren't using any kind of form of mobile device management. You have the concept called bring your own device, and unfortunately a lot of organizations aren't prepared for that. So they allow personal devices into their networks, and these are connecting to the enterprise network, and unfortunately that's an avenue into the network that bypasses the firewall and everything else. Some of the mobile application attack vectors that we see, legitimate applications from the phone's application store. Let's say that these applications may not always be checked to the degree that we would like. They're not always checked for security or functionality or even performance. So there have been cases of legitimate applications, even in the Apple Store and Google Play, that are insecure and they're downloaded to the phone and they have issues that could be attacked. Obviously, malware is an issue. Mobile devices suffer from some of the same malware issues that regular hosts do. Maybe the code is a little bit different and has to be platform specific, but there's still malware out there for them. Another hacking vector for mobile devices are the network connections themselves. Unsecured Bluetooth connections is a big one. A lot of mobile devices will pair with anything. Unsecured wireless network connections. When people are at home or at their business or in a hot spot at, say, the bookstore or a coffee shop, those wireless connections aren't secure, so the attacker has a way, an avenue to go into the device through an unsecure connection and get data off, potentially. There's obviously also the threat of device loss or theft, losing your phone or your tablet or having someone steal it and you don't have a pin locked on it, so you have to worry about whether someone's going to steal the data off of it. And unless you've used some kind of remote wiping service, that's a big worry. Now, jailbreaking or rooting the device, that's another topic for discussion, whereas people jailbreak it so they can get better functionality or more functionality out of it. In some cases, however, jailbreaking can cause problems. We also have, obviously, mobile web vulnerabilities that could come from some of the mobile sites that are designed for these small mobile devices. Now, in some cases, a lot of these devices will go out and use normal websites. And even in those cases, there's drive-by code that could conceivably be delivered down to the device and affect the device itself. And all of these issues can affect the applications. It's possible to lose a device, for example, and have someone hack it, and then they return it to you, but they've got some malicious code on there in the form of one of your applications. So even device loss, physical loss, or theft could result in application hacking. Now, briefly, there's several attack tools that are out there for mobile application hacking. Some of these obviously are specific to the operating system or the phone. Super One-Click and Super Boot are for Android, and they're basically used to root or jailbreak the device. Droid Sheet and Zitmo are other Android pieces of software that will install malware and affect the device. Cydia and Red Snow apply to the Apple iOS, and these are used to jailbreak the device and get software onto it. And even BlackBerry has a piece of software out there called FinSpy Mobile that will basically invade a BlackBerry device and take a lot of data from it. Now, there's obviously a lot of mitigations for mobile device security, and they're probably common sense, and a lot of them apply to regular hosts as well. Securing the device with a PIN or a passcode in case you lose it. Don't jailbreak it, because that can open up your phone to root access and allow malicious software and applications to get to the phone. Enable the phone finding service specific to the device. If you lose it, you can find it. Securing your network connections, obviously, is a big one. And also updating the device with patches and downloading software only from trusted sources, and backing it up, of course, is always good. So these are some of the mitigations you could use for mobile devices. I'm sitting here looking at an Android emulator, Android x86, which is actually a pretty cool little emulator, and it's actually for x86 platforms, computers that you might normally install Windows on, for example, or Linux. And I've got this installed into a virtual machine, although you can install it on a typical x86 platform. And to say it's an emulator may not be the right term. It actually seems to be fairly functional, whereas an emulator would only run in a sandbox and perform limited functions. So this may be useful for you from a security perspective to take a peek into Android and play with a little bit, download some apps, and check out security for yourself. It probably would be better to work with this kind of emulator than it would be to actually play with and destroy or brick an Android device, unless you just happen to have one sitting around that you don't care about. So let's take a look at this and see how it looks. And from a security perspective, again, this may be useful to learn on, but I'm not sure you would get a lot more out of it other than possibly learning how different Android applications may work, such as rooting software and some of the other stuff we discussed earlier. It has the typical Android apps on it. I just set this particular one up, and it took me through the setup just like you would a new tablet. And it's even got some dev tools on here, and I think that's very useful because it gives you the options of testing accounts. It gives you a bad behavior option here to crash threads and processes, report conditions, to slow up the tablet and so forth. So kind of interesting stuff there. And it also comes with a cache abuser where you can quickly or slowly abuse the internal or external caches. So using this emulator might give you an idea of how an actual Android device reacts when it's put under a load or under some stressful conditions. So there's some interesting things there in the dev tools. It actually will go to the Play Store, and if you want to, you can do a search on something like rooting the device, and you'll find that Google actually does not support rooting software that comes down from the Google Play Store. However, there are some things that kind of talk to you about rooting and kind of tell you how to do it. Some tutorials you can get. And I think if you search on root, there's actually a checker here that will determine if you have root access on the device or not. So that could be fairly useful. A slow connection here, so give it just a second. And if we were to come down here to the apps, one I saw earlier is root checker, and it basically lets you determine if you actually have root on the box or not. So it's kind of interesting from that perspective, and we can install it and see if this box has root on it. And it installs just like a normal physical tablet would install it. And we can go ahead and open it up here. A little bit of a disclaimer here. We say OK, and it's root checker basic, and it notifies you up here on the top that due to security concerns, Google bans application from providing root access. So you're not going to be able to root using any software from Google Play. And it also tells you will not root this device, will verify proper root installation. So if you do root it, this will determine whether or not you've done it correctly, apparently. So verify root access. Sorry, this device does not have proper root access. So kind of interesting app there, and an interesting emulator as well. So if we go back into Google Play, we could probably see other types of apps and so forth that might help us determine security. And as a matter of fact, we could search for jailbreaking and see what we get. So there's some interesting games here, and actually some apps that talk to you about jailbreaking iOS, obviously. So nothing of the kind that actually would allow you to jailbreak the Android itself, more than likely. Getting a little bit of a slower connection here. One note that you probably should know, if you have the Android software development kit, there's probably a much better emulator in that than this, because it allows you to interact with it from your desktop and provide different inputs and so forth. It's primarily for developers, Android developers, and there's a possibility that you could use security tools on it and better get an idea of the security features for your Android device. Again, no real jailbreaking applications here. You could look for security apps if you wanted to. We can see what we get from there. And there's some different security apps for Android, obviously. Mobile security and antivirus, AVG, a version for Android, Lookout security and antivirus. So this could also give you the opportunity to play around with some of these security apps to see how they work on an Android device. So again, from a security perspective, probably more of a training tool than anything else, more than a hacking tool, but it may help you discover some vulnerabilities or some methods to hack an Android device that you didn't know before. So just something cute to look at.